paper 1, as you can see that there is a simple question here. They're simply asking you to analyze the missing value for y to solve for the value of a, in this case in the chart. And as I look for the value for b, I'm simply solving for the x value in terms of the coordinate pairs. So if I simply look at this particular graph, I can see that I have 2 points where x is 1. One of them is the 0.15, the other one is a 0.18, and this answers y, a equals 8. For question part 2, for A2, looking at the values for b, if you notice the y values are 4, and there's 3 of them. So if I look across here, I can see that this particular point is the point where I have 3, 4. This particular point over here, I have the 0.7, 4, leaving me the only missing point, which is b, 4, which in this case means that b is equal to 5. So this point is 5, 4. So we found that the missing values respectively for a and b are given just by looking at the graph. So in this case, b is 5 and a is 8. Second part of the question tells you that we have to identify the mean, which is given to us as 5, 4, which is this point right here. And one of the tricks to getting full points is always to mark both 2 points, the intercept and the mean x and mean y point, when you draw an LSRL. So as I draw this LSRL, I need to make a note that the y-intercept, which you get from the actually running the linear regression, is approximately 7.04. So if I were to mark this about here for the intercept and noticing this point, I just have to make sure that my LSRL runs between those 2 points. So as I'm running my LSRL, there it is, that's what it should look like. Just make sure you always have mentioned or marked the y-intercept as part of your answer, and the mean x and mean y as part of your part of the included point of your LSRL. Part C, they're asking you to use the line of best fit to estimate the value of y when x is 6.5. So when x is 6.5, we're somewhere about here. If I scroll up and I tag this along, I'm about just slightly greater than 3. So let's say like a 3.0 something, 3.05, just to be conservative. If I wanted to do a little cheat here, however, one of the things that I could do, since I already ran the LSRL, is I can go to y equals, and I can go ahead and I can input the actual linear equation using the numbers obtained as such. And in doing so, when I hit graph, actually if I turn on the stat plot, let me do that first. Turn on the stat plot. I'm going to go scroll down to the scatter plot, and I'm going to go ahead and graph that. Let's see what's going on here. It was not happy.
The calendar is for us, it's not for the students. It's like, I agree with what you're saying, because the calendar is more for us. Like when
Technical issues here.
If I'm like disoriented, I'm like, okay, what am I doing
And I think
today?
this is what I want to delete actually.
Oh, 2-1, got it.
Take that off. I'm going to switch that out. I'm going to delete this out, put a negative, not a, okay. Let's go to graph, and always zoom 9. Zoom 9 is very helpful in cleaning out any statistics-based questions. So now once you've done that, you can go to second trace, hit value, and then notice it's asking for x, so just put in 6.5, and see it's about 3.08. I estimated 3.05. Remember, IB always gives you plus or minus 1 or 2 points for the margin of error.